We have two questions to tackle for the scatter plot problem, and we have a part A and a part B. We'll start with part A. According to the line of best fit, how many pints of raspberries would the grocery store be predicted to sell in a week when the price of raspberries is $4.50? Now, when we're dealing with scatter plots and lines or curves of best fit, when we're talking about values that are predicted, we're talking about values we read off of the line itself. Whereas if they talk about the actual values that are actually measured or recorded, that's where we would use the data points. But here, since we're talking about what would be the predicted number of pints of raspberries sold given this price, we're going to read this off of the line. So we're going to look at our x-axis where we see the price, and we find $4.50 right here. And so we're just going to go up to the line, and we're going to go across. And this is where, obviously on the real test, they probably would have to give us some choices because this could be read as 90 or 89 or 88. I believe the official answer here is 89. But point is, it's something around 90 because we're reading that off of the line. Now, we actually could get the answer more directly in this particular case because we do have the equation of the line of best fit. Not always going to be given to you, so I think just reading off of here is fine. And indeed, if we go ahead and plug in 450 for x, so it'll be 233 minus 32 times 450. I believe we're going to get 89 directly, which is, I guess, why they have an exact answer here. Yeah, but more importantly, again, they're not always going to give you the equation for the line of best fit, so you can just read it off of the graph. Notice there are no data points at 450, and this is kind of the point of building these lines of best fit. Like, we can have some idea, for example, if the price is $4, what the possible number of pints sold could be. But for 450, we don't. But since we have this model, since we have these scatter plot points that we are modeling with this line of best fit, we can at least make a prediction. If we were to set the price to 450, we would sell approximately 89 or 90, whatever. That's kind of the point of all this. Let's move on to B. For how many of the 19 weeks shown was the number of pints sold greater than the number predicted by the line of best fit? So here we're going to be comparing actual versus prediction values. So I wanted to determine for how many of the data points, right? They call it weeks, but that's because each dot represents a certain week. For how many of these dots is the actual number of pints sold greater than the predicted is essentially what the question is asking. So we just need to look at our scatter plot and see how many dots are above the line. So it's 1, 2, 3, 4, 5, 6, 7, 8. So it looks like it should be 8, and that would be our answer. So here we're comparing the actual data points to what's predicted. We also have some that are under the line. In some cases, you might have some right on the line. Nothing that special about it. It's more random that would happen. But at the very least, we know that, yeah, the points above the line tell us the actual values during those 19 weeks above predicted. So we get 89 for part A, and we get 8 for part B.